Hello and welcome back to Triplicate, home of interesting electronics. And today we're going to move on with the automatic cat food dispenser project. Last time we decided to replace the quartz clock driven mechanism with stepper motors. So we obtained some stepper motors and wired them up. So today we're going to find out how to get the stepper motor working and hopefully get it working. Okay, as I say, I've never used a stepper motor before, so where will I go to find out how to work a stepper motor but Wikipedia? So here we have Wikipedia's stepper motor article, and it's got lots of interesting details and equations and all sorts, and I'll leave you to read that yourself if you're interested. But what we're interested in here is this diagram. So there seem to be four ways of driving a stepper motor. Wave drive, you drive each of the four coils individually. Full step drive, here we have two coils on always. Half step drive, we have one coil, then two coils, then one coil, then two coils. And micro stepping, which uses analog outputs, which we won't use at all, with no facility to do that. And also, going back to the listing for the stepper motor driver board, they recommend 1, then 2, then 1, then 2, which is half step drive. Is that right? Yes, that's the half step drive. So in the first instance we shall implement that and see what happens. So I have here an empty Arduino project, so I am going to put some code in it and we'll see what it does. So I have pinched some code from another project just to get us going a bit faster. So that sets the 4 pins to outputs. We will again use the milli to generate a clock, so we have a tick time, and if millis are less than tick time we do nothing. And otherwise we add tick time millis to tick time, and we'll have a system count variable. Probably won't use it here, but we'll generate it anyway. So that gives us a tick, and every time we get our tick we will call, what should we call this? Motor next step. Okay. So I'm a great believer in letting the compiler do the work. So motor next step, it can't find that. So we will actually generate it at the top. This for now is just absolute test code, so don't complain to me about the structure or anything. Right, so we will have a step equals 0. We will have a step position, which needs to be a static uint t, and we will switch step step. So for instance, if step is 0, that is the first step. So each of these is a step. So phase A is output 0. So we have 0 and then 0 and 1, 1 then 1 and 2, 2 then 2 and 3, 3 then etc, etc. So switch not case 0. I've accidentally turned the caps lock on. You're probably realizing at this point why I normally do the typing and then bring you back and show you what I've got. But I thought on this occasion I'd do a bit of typing live, so to speak. So step 0, we want high, 0 high, and the rest low. And we want to set step equals 1. Step equals 1. Break. Right, and there will be 8 of these case statements. So I think what I'll do is I will turn you off, type the rest of it in, and then just bring you back, go through it with you, and we'll see if it works. Right, so here we go. Oh, missed. So tick time millis is set to 1000, so it'll move on 1 step every second. This is just so we can see the LEDs going through the cycle and check it's working right. So here we have the static variable step. If it's 0, output 0's on, 1 output 0 and 1 is on, 2 output 1 is on, 3 output 1 and 2 are on, 4 output 2 is on only, 5 2 and 3 are on, 6 3 is on only, 7 3 and 1 is on, and 7 goes back to 0. So it just goes round and round and round and does that. And that's it. So should we see what it does? Right, so we don't need the motor for now. Let's get that away. Let's just plug our driver board onto the Arduino. There we go. And let us plug the Arduino in. okay. I heard the computer registering the driver, and two of the little lights are on. So let us see if it'll work. Off we go. Right. And that seems to be working. So should we just maybe speed that up to 20 Hertz, which will be 50 milliseconds, like that, and run it again. Come over here. That doesn't seem to be quite right. 50 milliseconds. So perhaps we should try 20 milliseconds. Okay, we'll put that through the motor. It'll probably move very slowly, but hopefully it'll move. Okay, so actually I need to retrieve the power motor supply wire off there, so I need to turn the soldering iron on. So I'll do that, wire all that up, connect the motor up, and bring you back. Okay, so call me Mr. Paranoid, but I've decided I'm going to power the Arduino off this, which is a BlackBerry phone charger, so I shan't be needing that to charge Blackberries anymore, for sure. So we shall plug this in over here. I shall connect. No, I won't. I'll put the camera at it as well, so you can all see what I'm doing. Ah, man, that's it. I shall put that in there. Oh yes, I can see a light on. Maybe you can see that. Down in there, yeah, I think just. So the BlackBerry, the Arduino's powered, BlackBerry's powered. Right, so I am connecting the motor power from the power supply at 5 volts. However, I am initially going to turn the current limit right down. So the voltage has gone down. Excuse me. I am going to put it through the multimeter on milliamps, DC milliamps, so I know how much power it's drawing, and I'm going to plug the motor in. There we go. So the moment of truth. Will it drive the motor round? So let's gradually ease the current limit up. So the voltage has come up to 5 volts. Foolish, right. Turn the current limit back down. Actually, there we go. Connect the motor supply, I think. Right. Try again. Turn the current limit up very gradually. And still nothing. Right. It's on milliamps. Meters on milliamps. I might of course have blown the fuse in my meter. Okay, I might put it on to amps because that probably hasn't got a fuse in. So again, I will drop the current limit right down, pull the meter onto amps, put the plug, 20 amp fused it says. 20 amp fuse. I don't think I'm going to go through 20 amps. Still nothing. Right. Let's. Oh, bad connection. It's suddenly going. Oh, and we have rotation. And we have a current draw of, didn't like that, 250 milliamps. Oh, hang on. And if we go back to the power supply, I haven't given it enough current limit. So that's, let's turn that up a bit, 270 milliamps. That's quite a lot of current. Okay, well I think that'll probably do for this video. Thank you for watching. Hope you've enjoyed it. If you have, please subscribe to the Triplicate channel. Any comments you'd like to leave, please leave them. Give me a thumbs up. And next time we'll get into actually trying to drive this round at the speed we want to. So for now, it's goodbye from Triplicate, home of interesting electronics.